waiting for the page to open. There we go. Okay. Now, you have fx equals 2e minus x, and x is positive. And I want you to put boundaries on what values you can get. So let's start off by looking at f0. What would I get if I put in 0? 2. Okay? And if I calculate f infinity, what would I get?
Negative number, I guess.
Mm-hmm.
Infinity? Or
Yes.
okay.
Well, technically, yeah, it's approaching 0, isn't it? But it's not equal to 0. No, where have you guys been? Wait, what are you doing here?
I'm just
Are you just dropping them off, is it? You can come back in an hour to pick them up, okay?
Can you make it an hour now?
Come on, why are you so late, guys? I didn't get an answer.
I thought he was going to answer.
Another few minutes and I wouldn't have let you in, you know? Right, so you were saying it's not actually equal to 0, is it? It's just approaching 0. Is that okay with you? You were asking me about this. It doesn't quite make it to 0 because you can't really have an infinity here. It's approaching 0.
Why it's not negative?
E is never negative. You can check it on your calculator. It's always a positive number. So it means the smallest value I can get is 0. But do I even get 0? Do I get no? And the biggest value? 2. Can I get 2?
Yeah.
Yep, because I can just make it 0. So there you go. So that's the... Do you understand the word I'm saying here? Boundaries. That's the bounds. That's what it's restricted.
Why 2?
2 is the first one here. That's 0. 52.
Can you show, like another example?
52 number 7.
Yeah, let's do
C.
C. Yeah, let's do C. Yeah. Can you write that down? We'll have a look at C then. Can I scroll down? So you have fx equals 5 minus 2e minus x, and x is a positive again. So let's have a look at f0. We get 5 minus 2e minus 0, which is what?
3.
No, 3. 5 minus 2. Okay? Actually, I'll write that out. Is equal to 5 minus 2, which is 3. Now, let's calculate f infinity. That would be 5 minus 2e minus infinity. Oh, okay. Yeah?
We choose 0 because in the equation or in the question.
Yep. The x more than or equal 0.
What about the infinity?
Well, what we're doing is we're looking at the smallest x and the biggest x. So if I tell you x must be bigger than or equal to 0, the smallest it could be is 0. The biggest it could be is infinity. What do I get here? 5 minus 0, which is 5. So what's the boundaries here? What values must it fall between?
3 and 5.
3 and 5.
3 and 5. Oh, and which one can we have and which one can't we have?
5.
5.
So we
5 we
Cannot.
cannot really, and the 3
Why?
we can. Well, because we can never really have infinity. We can only have close to it. But we never can really have it. We're not really allowed to put infinity in as if it was a number.
How we got 3 in the first step?
5 minus 2.
E is to
5 minus 2 e power 0 is 5 minus 2. Because e power 0 is 1. Yes, no? I need questions. What's e power 0?
E power 0?
Yeah.
0?
No, 1.
1?
Yeah.
Okay, so 5 minus 3, 5 minus 2 is 3.
Correct?
Really?
Yes?
Then, okay, why? Okay. If it's equal 5 minus 2,
Yeah.
why do you like do it again?
I'm looking at f0 and I'm looking at f infinity. So I can get the lower value and the upper value. So this one gives me the lower value, f0, and this gives me the upper value. And the reason I choose 0 is because
Our minimum is 0.
minimum is 0.
Question.
Yes, which page?
42, 8.
42, 8. Yeah, that's a hard one. 8a?
Yeah.
We do? Yeah. Yeah. Can I scroll down?
No, just.
Just a sec, okay. Was Ray in earlier today? Or
Yeah.
he was? Okay. What's wrong? Oh, we can just close the blinds to be easier. No, I'll get it, it's okay. You write the bit. Alright, thanks. No, we'll leave the window open, we'll just close the blinds.
Ah. Yeah. Okay.
Oh, you still have a strip of line. Wait, which one is it? Is it this one?
No,
No, it's the other one? Yes, that one.
but I'm still like.
I don't mind, I like it.
Ah, okay. No.
Sign kid.
Alright. Okay. Page 42, 8a. Next. Do you have that, Hazza?
Yeah.
Yep. Okay, 42, 8a now. So I tell you that the 9th term in a GP is minus 6561, and the sum of the first 2 terms is 2. Okay? So this can be changed into a or power 8. And this one, well, it's the first 2 terms only, so it's a plus, what's next? First term is a, and the second term is AR. Ah, no. You know why, it's GP. Go A, AR squared, AR cubed. And this is equal to 2. Right. A equals minus 6561 over r power 8. And here you can take the a out and have 1 plus r equals 2. So you have a equals minus 6561 over r power 8. And here a equals 2 over 1 plus r. Okay. Now you can make these equal because they're both equal to a, aren't they? Yeah?
Which 1 plus R?
What did I take out here?
The A?
Yeah.
Ah.
Yes. Okay, so minus 6561 over r power 8 equals 2 over 1 plus r. Cross multiplying, I get minus 6561 over 2 equals r power 8 over 1 plus r. Now with fractions, you're allowed to put the minus on the top or the bottom. You're free to move it up or down. So I'll move it down. And the reason I'm doing that is I'm trying to match these two. Why did I move the minus down actually? I'm trying to make a match here.
So the R will be positive?
Nearly, yeah. or power 8, what do we know about it? We know it must be positive.
Yeah.
Why?
Because it's even.
Because it's an even number. So the minus couldn't be on the top, it must be on the bottom.
Yeah.
Yeah?
So it's 3.
So let's just see. It does look like 3, doesn't it? But we have to be careful with the signs. So we need a number to put here so that we get a minus 2. So potential, or well, that could be minus 3. And maybe minus 3 power 8 does make 6561. If it does, then we're finished. We've found the answer. Okay, so it's a hard one. That's a hard one. That's the hardest one on that page. Okay, if you can write that down.
For mine, did you get the rule A 1 plus R is equal to 2? It's
Where did I get which one?
the first row? Yeah.
This one?
Yeah.
Oh, that's S2, the sum of the first two. What's the first term? A. What's the second term? A or sum. Yeah. First term plus second term is S2.
That's the idea of
Can you do like C?
Yeah.
8?
Which one?
C8?
You mean 8C?
Yeah.
The ninth term. Yeah, okay, let's have a look at that. We'll do C next for this one. Okay. Can I scroll down?
Yeah.
Yeah? Okay. Right. C. So we have the ninth term is 256. And, what do I say? The sum of the first three terms is 3. So I get A equals 256 over or 8. And then you can use the formula now because now we're more than just 2. But you have a choice. You can either say A plus AR plus AR squared if you want to. Or you could use the formula.
What about the formula?
Yeah, it'd be A 1
Yeah.
minus or cubed
Yeah,
over
yeah.
1 minus or. But this actually is more work because you'll have to divide this into this. You know the long division? So I'll just leave it as what I had. A plus AR plus AR squared equals 3.
So it will give the same answer?
Oh yeah. Yeah. So this will be A 1 plus or squared equals 3. So I get A equals 3 over 1 plus or squared. And again, they're both A, aren't they? So we can say 256 over or power 8 equals 3 over 1 plus or squared. Cross multiplying, we get 256 over 3 equals or power 8 over 1 plus or squared. Now, I'm going to do something sneaky here. I'm going to change this to... no, actually I'll leave it like that. It's fine. Okay, so we need to think of a value of or so that if we make it power 8, we get 256. And if we put the value in the denominator, we get 3.
Minus
It has to be minus 2, doesn't it? Because minus 2 power 8 is 256. And 1 plus minus 2 plus minus 2 squared. 1 minus 2 is minus 1. Minus 1 plus 4? 3. So it has to be minus 2. Couldn't be anything else.
So like we need a number to equal to 246 over 3?
Yeah, we need to find an OR here to make this fraction.
But why it's 256
Mhm.
over 3? Why 3?
3 was here.
Yeah, why
It's
is
dead when you first multiply.
Yeah, brought that down, brought that up. Yeah? Yeah. Okay. What do we need to see next?
That's a limit.
Limits, yeah?
Maybe.
Okay, problems?
Well, you had a couple of questions. We'll give someone else a chance first.
Limits?
Because I'm used to limits, like applying it in the calculus part, like with derivatives, stuff like that. So
Yeah, yeah. So,
this is almost new to me.
what one do you want me to do?
So.
Hmm?
44.
You have a question too. 36, yeah? Which-
4B.
4B. Okay. So while you're looking at limits, or do you have one already?
3B.
Okay, so we'll do that and that one. So we'll start with 44, 3B, and then we'll go to 36. (3b), isn't that what you said, Aziz? Yeah. So un equals minus 8n squared minus 5n minus 9 over minus 8n squared plus 2n. No, I'm mixing myself up, sorry. Oh. No, that's it, isn't it? Yeah. Now, the limit means what happens when this goes to infinity. If you try to put infinity in, you get a bit of a problem, because you'll get minus infinity, minus 9 over minus infinity plus infinity. It's not exactly clear what this should be, if it even should be anything. But there's a trick here to help you out. Divide. Divide by what? Divide everything by n squared. Yeah. So you change the problem from this into this. 8n squared divided by n squared is 8. 5n divided by n squared is 5 over n. Yeah. And then 9 over n squared. Minus 8 plus 2 over n. Now this is much better, because if you put infinity in now, you get 8 minus 5 over infinity, minus 9 over infinity, minus 8 plus 2 over infinity. Now why is that much better? Because you know what this one should be. What should this be? 0, 0, 0. So it'd be 1, yeah. Okay, in a moment we'll do, what did you say, 36, what one did you want?
Is that supposed to be a negative one?
It's minus 8 over minus 8, it looks like.
Yeah.
Oh, okay. Is it have to be
Page 36 4B, do you have your calculator? We'll need a calculator for this one. Okay. So I tell you that xn plus 1 equals minus 5 minus 7 over xn. And I tell you to start with minus 4. So that's the first term. The second term will be minus 4 minus 7 over minus 4, which is minus 5 plus 7 over 4, which is,
What question is
Is it B?
there it is,
Minus 13 over
minus 13 over 4.
4B, I guess.
That's
Maybe.
It's, guys, I say it right on the top.
yeah, but it's not. I don't think it's 4B.
What are you talking about? Isn't it?
Oh wait, never mind.
Are you on the right page?
Yeah, right.
Okay, right. Right. X3 will be minus 5 minus 7 over minus 13 over 4.
minus 37 over 13.
Yeah.
And then X4,
94 over negative.
you have the next one, what is it? Well, let me write it down. It's minus 5 minus 7 over minus 37 over 13. And what do you get?
Minus 94 over
No.
Minus 94 over...
37.
Yes, 94. I did.
Okay.
34.
and then it continues like this, doesn't it?
Yeah.
Yeah. So that we can...
Divergent?
No, because if you change these into decimals, it looks a little bit clearer. Because what was
No,
the
it's
first one?
convergent.
Yeah, it's minus 4, isn't it?
Yeah.
And then what's the next one?
Negative 13 over 4.
Yeah, but as a decimal. Is that 3.25?
No, it's divergent. That's the thing.
Negative 3.25, negative 2.84.
Yeah, it's like this, isn't it? If you put them into decimal form.
But it's
And then
divergent.
No.
X
No, it's
times
this.
1 and negative
No.
4, so
Keep going,
Because this one is equal to
keep going. It's looking convergent, isn't it?
yeah, that's a target.
Minus
That's
2.24.
a hina.
the answer.
That's minus
Very
1.
good, basically.
It jumps, you sure, from minus 2 to minus 1? Oh, minus 1.88.
I couldn't go down,
It's, no, hey, English.
Sorry.
Okay, English.
Why is convergent? This is divergent.
Yeah, it's divergent.
Because
And the
it is
calculator, let's see.
Convergent.
It's a divergent. I wrote divergent.
Divergent. It's divergent.
Oh, you think it's divergent, is it?
No.
Is it not set? Is,
Oh. Linear formula.
well, you're right, it's not really settling down, is it?
yeah.
Yeah.
So, yes, I'm looking at the terms here, they're jumping around. They're not convergent to anything. Yes, but Japers, it went like minus 0 point something and then it jumped to 546. And now it's back at minus 5, now minus 3.6, minus 3, minus 2.7, minus 2.4, minus 2.1.
It's repeating.
No, I don't even think it's repeating.
No,
It's,
it's not
it's not repeating. It's jumping around wildly.
Divergent.
Minus 19. Yeah. Yes, you're right. It's divergent. It's not moving to anything. That was a tricky one.
Well,
Yeah.
So like in this question, for B it's like 7 over xn, but like in some questions it's like un minus 1. How does it?
Yeah, it doesn't matter. You see, it's just your choice of vocabulary. So
Yeah.
here, xn plus 1 means the next term, and xn means the present term. But if I use minus 1, like in the next one, C, then all I'm saying is the present term is equal to twice the previous term.
So it's just the same.
It's almost like different grammar. So you can either give your formula as the next term is something acting on this term, or you can say this term was some action on the previous term. It's still neighbouring terms. You get what I'm saying? Now, what's interesting here for your question is this is divergent. So I do wonder what would happen if we tried to find the limit, because it's not supposed to have any limit. So let's use the technique to find the limit to see what would happen. So you would get x infinity equals minus 5 over 7 over x infinity. Or rather, it's kind of like x infinity plus 1. what we're actually assuming here is that neighbouring terms will be similar. Do you understand? Like, what we're kind of assuming is x 1001 would be roughly equal to x 1000. Now, why might that assumption be wrong? Well, as we were looking at the sequence, what's happening to it? It's jumping around. So, we're probably wrong in this assumption, but let's see what happens anyways. X infinity squared equals minus x infinity minus 7. Minus x infinity squared plus 5x infinity plus 7 equals 0. And the discriminant here is negative, isn't it? Which means no solutions. So it couldn't, not possible to have a limit. We can't find it even. So clearly no limit. And no limit means divergent. Yeah? Yeah. Okay, that's fine. No, there we go. Yeah, we can do some more.
The question you gave us in class about the hexagon and the triangle on top,
Yeah,
how would you solve that without the 60-degree hints?
You can't.
You can't?
you can't. Which was why I was so surprised you were convinced you could.
So what?
I'm playing mind games with you. You need the 60 degrees. You need another piece of information. But you were so adamant.
You can use n minus 2 times 1/8 to find the degrees inside the shape.
Yeah,
Yeah, but
Yeah.
you should know the degree of the triangle.
you need to know something about the triangle on the top. But you were so convinced that you could.
If
I
could
didn't.
get the inside.
I did. You were so convinced I didn't want to burst your bubble. So when you said you could find the solution, I said, okay, fine, go ahead.
You make him believe.
I did, yeah. And I did that on purpose. And I'm sorry, I was trolling you a little bit. It's just you were so convinced I didn't want to break your dreams. But I'll tell you the harsh truth now, you can't. Yeah. So, that's heartbreaking, I
I
know.
have a question.
Yeah,
Page 28.
confidence is key, yes. Yes. 28,
Yeah.
which one?
2G.
2D. Okay, let's have a look.
G.
G.
G. Ah, we did this one in class, didn't we? Yeah, we did. We did this one in class. Check your notes there. Just have a look.
Yes, I
don't have
didn't
to
solve
lie.
it.
Guys,
One line.
2G.
Yeah.
Didn't we do this one in class?
Yeah.
I'm pretty sure we did. You should have it in your notebook. Or did we do it in a tutorial? We did it though.
Yeah.
We did it, didn't we? Yeah. Yeah. Do you have a question? Or which one?
Yeah,
No?
Wait, question?
Yeah. No? Okay. Yeah?
Yeah, number 2. I see 2F,
On which page?
28.
28. Yeah, okay. I didn't do that one. Right. Can I scroll down? Page 28, 2F. Minus 11x minus 14y plus 27 equals 0. Minus 2x squared minus 7xy minus 5y squared equals 0. Now, there is an easy way to do this, but it's only well, subbing is one way to do it, yes, but I think there's an there's an easier way, possibly, to still need subbing. If you can factorize the quadratic here, you should. So let's see if we can try and find factors here. Guys, I want only English, please.
I just speak to you.
Okay, fine. Whoever's speaking.
-1.
Right, the next time there's non-English, you're going. Right, now hang on, let's see. A minus 2x here and maybe x here. We'll make minus 2x squared. Y and y, one of them needs to be a minus and one of them needs to be 5.
Yeah.
5 here?
Yeah.
5 here, yeah.
It's negative 1.
This one is minus, you think? And this one is plus. Minus 2x squared, minus 5y squared. No, that's not quite right.
Minus 5.
I think the signs are wrong. What did I just have?
Minus.
I had a plus.
Yeah.
Yeah, so it's minus.
Minus plus maybe?
Mm,
Yeah.
Yeah.
Yeah, that works. That works. I factorized it. Okay. Now, so I'm keeping the first guy the same, but the second guy I'm changing into this, which I'm going to change now into this. Now, can you see why that's the same statement? If I tell you I have two numbers, A and B, and when you multiply these two numbers, you get 0. Okay? What do you know about these? Well, it must mean that either A is 0 and B is not 0. A is not 0
B is a 0.
and B is 0.
Or both.
Or could A and B could be 0. So that's kind of the logic here. Maybe this is 0 or this is 0, or potentially both could be 0. Okay? So what you can do is change the problem now into this. Minus 11x minus 4y plus 27 equals 0. And minus 2x minus 5y equals 0. Or minus 11x minus 14y plus 27 equals 0. And x plus y equals 0. So what I've done is, instead of having one linear and one quadratic, I've split it into linear, linear, or linear, linear. It's a trick. Otherwise, I would be substituting the linear into the quadratic, which makes it, it's very messy. Very messy when we did that in class, but possible. Now, this one here is actually not too difficult to solve, because x plus y equals 0 means x equals minus y, so you can get minus 11x plus 14y plus 27 equals 0. So that means 27 equals 3y. So what's that? Y equals 9, isn't it? And then x would be minus 9. The first one's a little bit harder to solve, but again, not impossible. So you could rearrange this one here to say x equals minus 5 over 2y. Couldn't you? Yeah. And then you can sub that in. 55 over 2y minus 14y plus 27 equals 0. 55 over 2 minus 14, what's that? 55 minus 28, 27 over 2 y equals minus 27. So what does y equal? Minus 2, yeah. So y is minus 2, and that would mean x is 5. Okay.
I did it.
By subbing in?
Yes, but
Good.
I got different.
Because with subbing in, it's easy to make a mistake. It gets quite complicated. Well, let me just check if
So
this is
negative
even.
4, 9.
Which one?
Is that I did it, or I get
How'd you get this?
9
It's
and 5
7 multipliers.
But where's the? That's like.
Oh my god.
I don't think you expanded right here. Where did the square go?
No, I mean like I took this one.
Yeah.
I bring this one.
Oh yeah, yeah. But on this line here, how did you get this?
times this plus this.
Yeah, but you have to square it first.
And you mean like I'll have to
Mhm.
square this one?
Mm-hmm. That has to happen first. Yes. Is this right? Sorry. Which one is this? Which number was this?
2 half.
Do,
2
2, yeah, 2,
It's right? Yeah. Yeah? Okay. What else do we need to see? Oh God, we can do one more.
Page 54.
Yeah?
6B.
6B. Yeah?
Yeah.
Okay. Log base 2, 8x plus 1, minus log base 4, 9x minus 9, equals 3. First things first, let's figure out the possible domain for x. If you look at this, you can see that 8x plus 1 must be positive, right? And here, 9x minus 9 must be positive. So that means x must be more than 1. And here, x must be more than minus 1 over 8. And the connection here is an and. So if x must be more than minus 1 over 8 and x must be more than 1, then we can say
X more than 1.
x must be more than 1. So we know that our answer must be more than 1. Now let's go back to the question. What's the problem with this log equation?
Bases.
The base, what's wrong with the base?
They're not the same.
Yeah, so what should we change? Which one, yeah?
How do we know that x more than 1? We just like.
Well, I just think it, like, what I'm saying is x must be more than minus 1/8. And x must be more than 1.
So it's all of that.
Yeah, like, what's the only way you can have both being true at the same time? Is if x is more than 1. It's the only way to guarantee both are true. Which base should we change?
Minus 4.
Yeah, to what base?
To
Base
0.
2.
Now, do you remember how to change the base to any base you want? So you change the base to the base you want, but then what's the price you pay? You must divide by log
2.
old base, new base. Oh, sorry. I said that backwards. New base, old base. What is log 2 for?
2.
2, isn't it?
Yeah.
So that's a half log base 2, 9x minus 9 equals 3. Now what can I
Divide by what?
divide by?
Oh.
No, what should I do next?
Wait,
Insert
Again what? What's log 2 for?
Oh, yeah.
Yeah. So what's next?
Bring the half, make it a power.
Bring the half up as a power, isn't it? So what power do I have here? What power is up here? A half. But what's the power? Yeah, power half means square root. Now, what does the minus do here? Divide, isn't it? I'll take the 9 out actually. Okay. Now, do you remember what the meaning is here?
Yeah.
2 to the power of
3.
3 equals 8x plus 1 over
3.
3 root x minus 1. It's rearrangement just. Right, now what should I do next?
No, multiply by square of.
Square everything.
Yeah.
2, this here is 8, isn't it?
64.
64, yeah, 64 equals 8x plus 1 squared over 9 x minus 1. Yeah? Isn't it? Yeah. Right, can we bring this guy up? What's 64 times 9? Something big.
576.
576x minus 576 equals 64x squared plus 16x plus 1. 64x squared, 16 minus 576?
560 minus 560 plus 577.
577. And this has two solutions. Are both of them more than one, or what's this?
Yeah, both of them are more than one.
So both of them work? So what are the two solutions to this? Decimals, right?
1.193
1.193
or 7.557.
using the quadratic formula. Okay. Hard one. Yeah.
Took a day for me.
Well, that was a day well spent, I would say. Yeah. You want me to check your attempt, is it? Or?
Because it's different. Because I use like this to something.
Oh, use this formula. I didn't teach you this formula, but that's fine.
So I can still use it? Because I prefer this one that way.
Oh, fine. Fine. Yep, no, that's fine. But
Thank you.
Show me
Yeah.
your phone.
Is it easier?
no. No.
It's dangerous.
Right, off you go.